Time to have fun solving equations. First, let's look at the definition of what the heck is an equation. Well, if you saw my previous video on expressions, then it's going to be easy to define what an equation is. An equation is two expressions with an equal sign in between. Now, in my video on expressions, one of the things that I mentioned was that you can't solve an expression. You can only simplify. And occasionally an equal sign would appear, but it was not in between two expressions. So the equation is different in that regard. And let's take a look at a quick example so that I can show you what I'm talking about. If I have something like this, like, let's try 3x minus 7 plus 2x times 5x minus 3. And if I want to, this is an expression. Notice there's no equal sign anywhere here. However, when I go to simplify, I will write an equal sign off to the right to indicate that the next line that I write is equivalent to the one above. But there's no solving here. There's no way for me to solve for a value for x. Now, let's compare that and contrast that. And you might want to pause that. Well, you could write this down if you need it, but you don't have to write it down. I'm going to go ahead and get rid of this. And instead, let's look at a simple version of an actual equation. For instance, if I have something like 3x minus 5 equals 11. Well, that's a perfectly legitimate equation. On the left, I have an expression, 3x minus 5, and on the right, I have an expression, 11. And believe it or not, 11 is a legitimate expression. And I'll talk about how to solve this in a minute, but I wanted to see contrasting examples of what's an expression and what's an equation and how they're different. And feel free to write down some notes explaining to yourself in the way that you understand best. Another thing that I'd like to take a moment to talk about is a concept called solution or solutions. Solutions is a big important concept when having to do with equations. And the definition of solutions, and I'm not sure whether I use the word is or are, but solutions, let's say are, solutions are values that make the equation true. Solutions are values that you could put in a variable and I'm just going to simplify this. Values that make the equation a true statement. So that's what the definition of solutions are, and specifically their values for a variable. Maybe we can go ahead and add that in. That's what I was looking for. Values for a variable, or variables really, but for now, for this chapter on linear equations, we'll just deal with a single variable for solving. So anyways, solutions are values for a variable that make the equation a true statement. So let's go ahead and take the example that I started with, 3x minus 5 equals 11. What we'd like to know is what value of x makes this a true statement. In other words, what value of x makes it so that 3x minus 5 is 11? Because if 3x minus 5 is 11, 11 equals 11 is a true statement. You with me? Okay, well, let's do the math. We'll do a couple of things. First of all, we're going to use the golden rule of equations, which is whatever you do to one side, you got to do to the other. I'd like to get rid of this 5 because I'd like to isolate this variable x. So I'm going to go ahead and add 5 to both sides of the equation. And when I say both sides, I mean both sides of the equal sign. That equal sign is like a dividing line. We're going to try not to break that. And so let's continue on. So now we end up with -5 plus 5. That gets me 0. And then we have 3x. 3x plus 0 is, of course, just 3x. And then on the right side, we have 11 plus 5, and that is 16. And the good old equal sign is still right on that line. So 3x is on one side, 16 is on the other. I just added 5 to each side of the equal sign. All right. And by the way, let me say a couple things here. When I add the -5 plus the +5, these two numbers are known as additive inverses of one another. Because when I add them together, I get 0. When I add the 0 to the 3x, the 0 sort of goes away because 0 plus 3x is 3x. And so 0 is known as an additive identity. Those are properties that are described in your book, and I thought I would take a moment to mention them. And in fact, maybe we'll go ahead and we'll write it off to the right like we've done in the past. Additive identity, that came from adding identity. That came from adding the 0 to the 3x and just getting 3x. And then up here we do, we do two things here. We use the additive inverses, but there's also another thing that we do is we are using a property of equality. It's called the addition property of equality that says I'm allowed to add something to both sides as long as it's the same thing that I'm adding to both sides of the equal sign. So we'll just go ahead and add that in, the addition property of equality. Now I'll admit I don't force people to refer back to that property that often. I may mention it. Addition property of equality. But in a minute I'll talk about some properties of equality that you should know and you should refer to. So anyways, then we'll go ahead and we'll divide both sides by 3 to get we're trying to isolate the variable x. Again, if I ever ask that question in class, what's another name for solving an equation? You're going to say isolate the variable. You can say find x, that's good too, but if you want to be really cool, you're going to say isolate the variable. That's another name for solving the equation. In this case, we get x equals 16 divided by 3. And if you really want to be fancy, you could write that out as a mixed fraction. And what is that going to be? 3 goes into 16, what? It goes up to 12 4 times, so one more, 15. So it goes, you could have 5 3s, and then I guess we have one left over, so 5 1/3. 3 times 5 is 15, plus 1 is 16 thirds. Just to remind you, in case you forgot, you can also do this: 16 divided by 3. 3 goes into 16 5 times, gets us 15. That's 1/3 is the remainder, 1/3, so 5 1/3. By the way, this will come in later as well. Another way to write this is 5 plus 1/3. Again, if for some reason you have a problem with that and you want clarification, let me know and I'll be happy to explain it. Mainly on my tests, what you'll see, the answer should look like x equals 16 thirds or 5 1/3. Later on, when we talk about polynomials, we'll deal with this. Let's look at another example. Here's another issue that comes up frequently when solving equations. Let's look at an equation to see what I'm talking about. Sometimes you have something like 7 equals x minus 3 divided by 2. And we want to solve this equation. The way that we'll do it is we need to multiply both sides of the equation by this number 2. That's what's going to, we want to isolate the variable That's how we solve the equation. And to isolate this variable, we need to multiply this side of the equation by 2, this side of the equal sign, and we'll multiply this side of the equal sign by 2. And when we do that, that's a little bit like, just in case you're wondering, well, what the heck? Why is he doing that? Well, it's because this 2 is like 2 over 1, and I'm allowed to cancel that 2 with that 2. In other words, 2 divided by 2 is just 1. And so that gets rid of the 2 on that side. Now I'm stuck with the 2 on the left side, and that's okay. So let's get back to our problem. 2 times 7 is 14, and that's on the left side of the equal sign. On the right side, I'm left with x minus 3. We'll go ahead and we'll use the addition property of equality again so that I can get rid of that 3. So I add 3 to both sides. 3 is the additive inverse of negative 3, and therefore I'll get 0. And 14 plus 3 is 17, and that's equal to x plus 0. And we just forget about the 0 because the 0 is the additive identity. In other words, x plus 0 is x, so we don't need it. Now, the new twist I'm going to add in here is this. I'm going to go ahead and swap the x and the 17 on both sides of the equal sign. And I'm going to go ahead and write out, and I want you to copy down, what's the reason why this is allowed? It's the symmetric property of equality. The symmetric property of equality. It's in the book. And I'm not that big of a fan of these properties of equality, but here's one that we'll be using pretty regularly, swapping things on both sides of an equal sign in an equation. And so probably couldn't hurt for you to know that it has a name. And by the way, hopefully you've heard the word symmetric before. It just means the thing is the same on one side as it is on the other. And so what we're saying is that if 17 equals x is true, then x equals 17 must also be true, because here the x is equivalent to 17. So what difference would it make if I rewrote the 17 there and the 17 there? It's the same thing as the step above. Okay, let's take a look at one more example, and maybe even more than that. The next thing I'm going to talk about is a neat property called the substitution property of equality. But before I do it, well, let's take a look. I'll walk you through an example. If I tell you that a equals 3, and then I say that 3 times a plus 5 minus, what the heck, let's say minus 7x. Let's say I want to simplify this expression. Then I am allowed to substitute that a equals 3 in place of the a that we have right here. And in fact, I didn't even need to have parentheses around the a. I could have just written this as, it would have been just fine if it was 3a plus 5 minus 7x. But I'm going to go ahead and substitute the 3 in there. So this becomes 3 times 3 plus 5 minus 7x. And the step that I did right there is known as the substitution property of equality. And again, the substitution property just means of equality. It just means that, hey, if two things are equal, I'm allowed to swap out one for the other. And so in this particular case, when I said that a equal 3, it meant that wherever I wrote an a, I was allowed to replace that with a 3. Now, I will tell you that this can get a little tricky. I'm not going to go ahead and simplify this. I just kind of wanted to give you a quick example. Let's take a look at something else. Where it gets really tricky is when we have negative numbers. So if I say b equals negative 3, and then I look at something like what is negative b squared? This is always kind of an interesting problem. I'm going to go ahead, again, that's just an expression. We're not solving. So I'm going to go ahead and I'm going to substitute the negative 3 in for b. So I'm going to write the negative sign, and then I'm going to treat the b itself like a set of parentheses, and then I'm going to go ahead and substitute that negative 3 in for b, and then I'll say squared. And then according to PEMDAS, the next thing I'll do is I'll do exponents and then multiply times the negative 1. So this will get me negative 1 times negative 3 times negative 3. And in the end, that gets me negative 1 times positive 9. And that is negative 9. Okay, and that was again by virtue of the substitution property of equality. Now, these are rather simple examples of substitution property of equality. When we go to do solving systems of equations, we're going to do some stuff that's a little bit more wild, and I'll show you right now just an example of what I'm talking about. This next example is a little advanced, but I just want to introduce it to you while we're talking about the substitution property of equality. Here's two equations, x equals 5 minus y, and another one, 5x plus y equals 13. And if I am told that both of these equations or both of these statements are true, then and that this x is the same as this x and that this y is the same as this y, then notice how in this first equation I say that x equals 5 minus y. Well, that is an open invitation to substitute 5 minus y for the x down there. Perfectly legal. Substitution property of equality. I'm going to go ahead and write it out and show you. And I'm not going to go much further. I'm going to rewrite the 5 here, and then I'm going to write parentheses. And then I'm going to go ahead and take this 5 minus y, this guy right there, and I'm going to go ahead and write it in place of x, just 5 minus y, and then I'll go ahead and finish off writing the rest of this. So plus y equals 13. So essentially I've written the bottom equation, by the way, I'll number the first equation 1, and I'll number the second equation 2. So this is just equation 2, where I substituted x with 5 minus y. So again, I'll go ahead and write it out. This is the substitution property of equality, and it's going to be real important later on. So not a bad time to at least get familiar with it. I'm not going to go much further. If you're curious, ask me in class. Maybe we could talk about it. Let's see, what else? There's other situations where we need to use the substitution, and they're advanced, and I'm going to show you because I want you to see future applications of this. Again, here's kind of an advanced application we'll see later on, but again, this is why we're learning it now, because of the substitution property of equality. 3x squared plus 12x minus 15. One of the things that, and what the heck, we'll throw in equals 0 just for fun. One of the things we're going to talk about, and you've probably seen it before, is called factoring. In order to factor we can factor this in order to solve, and we'll learn about that later. But for now, let's factor. There's two factorings we're going to do. First, I'm going to go ahead and factor out a 3 from all of these terms. 1 term, 2 terms, 3 terms. And when I do, I have 3 times x squared plus 4x minus 5. So that's called factoring out the greatest common factor, or factoring the GCF. Now that I've done that, I'm going to use a fun technique that is known as, I call it the X factor. Actually, a student named it for me. Some people call it diamond method, but we're going to go ahead and factor. And when we do, we put the 4 down here and negative 5 up here, and we're looking for all the factor pairs of 5, which there's just 1 and 5. We put the number 1 here, the number 5 here, and we'll go ahead and make the 1 negative. So 5 plus negative 1 is 4, and 5 times negative 1 is negative 5. And essentially what we did is we came up with two factors that can be multiplied together to get me x squared plus 4x minus 5. So that gets us x minus 1 times x plus 5. And here's the reason why I wanted to show you this. It's because even though I just factored this x squared plus 4x minus 5, I'm also going to, I still have that 3 out in front, and I still have equals 0 here. I want you to notice how neatly what I did was I figured out, by the way, if I take x minus 1 and multiply it times x plus 5, I will get x squared plus 4x minus 5. That means that this thing down here is equivalent to this thing right here. They are the same. And if that's true, I am allowed to use the substitution property of equality in order to rewrite this equation down here. I'm allowed to rewrite this equation like this because all I'm doing is substituting this for this. That's all. So let's go ahead and make a note. This is the substitution property of equality again. And as I said earlier, I'm not that big of a fan of you knowing all the properties of equality so well, but here's one that just comes in handy so much throughout this course. You should really know it well, that you are allowed to substitute two things when you know that they are equal.